it. You see, the routers and switches, they are very good in routing and switching. But if you analyze the traffic, we have varieties of traffic. Some are UDP traffic, some are TCP traffic, some are very time sensitive traffic, some are too big traffic, some are very tiny traffic. We got varieties of traffic. See, we have different age group. If you're going for VBS, many countries, this month is a VBS month, Vocational Bible School. Have you attended VBS? Okay. For kids, in various churches, they conduct VBS on summer occasion. So usually how they do is they bring children. Topic will be one single common topic, like following Christ. But not everyone will understand when you speak in a level. Everyone needs different level. Means every age group needs different level of delivery. We cannot speak to a kid of 6-year-old, 4-year-old, and 5-year-old between 3 to 6. You cannot speak to them as we speak to adults. They won't really show interest if you are not using those cute words. They will not be interested. Kids needs different level of treatment, even though the topic is same, following Christ. But the way that we deliver to adolescent, adult, youth, kids, they're all not same. The topic is same, but the way that we deliver, the materials that we use to display, they're all not going to be same. Even the teacher's skill set should be different. The kids teacher may teach very well to the adult, but adult group teacher cannot teach. All adult teachers cannot teach the kids group. Definitely the kids group people can teach very well to adults. When a kid can understand, definitely adult will understand, but adults teacher won't be able to deliver that effectively to kids. Likewise, the router also need to know to treat the traffics in a different way. The routers also need to know how to treat traffic when it is tiny traffic, when it is large size traffic, and when it is time sensitive traffic, when it is TCP traffic. The routers need to know to provide different level of service. For example, big traffic versus tiny traffic. Both comes at the same time. Which one to prefer? What you will do? So a tiny traffic is coming and a large size packet is coming at the same time. A large size packet only 3. Tiny packet somewhere around 30. Which one you will treat first? Correct. Exactly same. Yeah. You see, what you said is correct. The first one is also correct. Second one is also correct. The tiny traffics, they are very tiny. Even though they are many, the time taken to process is not much. So it is good to send all the tiny traffic and then the large traffics. See, that is how we all will think. And that is how network also need to do. But in general, routers don't do that. For router, first come, first serve by default. First come, first serve. Whichever enters first will get processed by the processor and will be sent out first. So when there is a large size packet and there are some tiny packets, whichever goes inside this hardware queue, there is a buffer on every physical interface. Understand? There is a queue on every physical port. There is a queue on every physical port. There is a buffer on every physical port. Whichever the traffic that enters that buffer will get processed first. First in, first out. Even here, you have tiny traffics. You also have a large traffic. Now, which one to send through the hardware buffer out? Whichever is coming first from the processor will be sent inside this, put inside this hardware queue to go out. So it is first in, first out, the default QoS, which is not really satisfactory in a real network. Maybe children of same age group, you can say first in, first out. But when there are different age group children, there should be a priority. You see, when we board a flight, all our economic class, let's say there is no business class and first class in that flight, there is no seating for business class and first class. All the passengers are economic class. Some countries are very stupid. They will say first in, first out. I have seen that also. When they board the flight, first in, first out. Or they'll say passenger seating from seat number 14 to 30. Come forward. That is for their own convenience, they are doing it. But there are some decent airports, decent people, good administration, where they will first call the people in the with the maybe with the wheelchair first. All the wheelchair passenger come forward. Second, you know it, all the parents with kids. Yeah. Mm, mm, yeah. 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 See, they give priority for the diplomat, for the needy ones, for the kids, and then they say rest of the passenger from seat 17 to 30, something like that. So that is what quality of service. If no quality of service, then what is the problem? The problem is the old people, the people who cannot walk, the kids, they all will get uh, rejected. Sometimes they won't get the privilege of enjoying the flight. Instead, they will get into trouble. They will be bothered a lot. So the needy ones need to be given priority first. You can't. So prioritization always makes the customer happy because the needy ones are also enjoying the flight like others now. Yeah, prioritization is very important. Likewise, in networking also the tiny traffic, like we treat the kids, the wheelchair people as tiny because they're very sensitive. They need help. So they're like tiny traffics. We serve them first and then we bring the normal customers in. Likewise, in networking also, if you allow the large traffic to go, then it is going to consume the bandwidth and the CPU for long. And there will be too many tiny packets waiting, too many. But if you allow the tiny traffic to go in, there will be few number of large traffic. When you count the number of packets, it will be less. So many versus less. If you see that, then better send the tiny packets first and then the large one later. Okay, so now what is next is this is achieved through various queuing mechanism. But before we get into mechanism, queuing techniques, queuing methods, we need to first of all know what is quality of service. What did you understand so far about quality of service? There is the definition also. Tell me, what did you understand? Hmm. Okay, good. So let me give my version of quality of service. If you like my version, you can take it. Quality of service is making the devices like switches and routers to get a new ability of identifying or classifying the traffic based on the classification, applying a set of priority level to those classified traffic is quality of service. I repeat, quality of service or queuing of service is adding the ability to the routing and switching devices in the network, the ability to classify, differentiate different traffics. First of all, you need to differentiate the traffic. This is tiny, this is big, this is time sensitive, this is UDP, This is easy. First of all, the traffic need to be identified, differentiated. After that, to the differentiated traffic, according to what it has been identified, the importance, the prioritization, the preference, the reservation is added. According to the reservation, according to the prioritization, when the packet arrives, the CPU will treat, the buffers will treat. The packet with high priority gets the first in the queue by making others to wait. Like we have, the business class people always gets the highest priority. So when you board the flight, you get the privilege of diplomat, right? Okay. So quality of service is queuing of service, deciding who goes in the front of the queue. Based on that, the packet is going to be placed in the front of the queue, and the one in the front is getting the first preference and getting processed, going out. So that is QoS, quality of service. Now, very, very important point to be learned here is whatever the quality of service you apply, that is going to be first in, first out, and there is no congestion. I repeat, only if congestion occurs, the quality of service that you are going to apply will take effect. The prioritization, everything will be given only if congestion happens. If no congestion, normal first in, first out only. Because it is not congested now. See, when you have enough of bandwidth, when we have enough of bandwidth, tell me why do we need QoS? Not necessary, no? When we have enough of bandwidth, we really no need QoS. All can freely go. Yeah, all can freely go. So quality of service is only applicable when there is congestion. When the counters are all empty, no problem. Whether he's a business class or first class or economy class or diploma, whoever, counters are empty. Go. There is no need of prioritization. Same thing applies in the route. So don't expect always an output for quality of service when you apply it. Sometimes you will not see output even after applying it. The reason is there is no congestion. Okay. Now, first thing in quality of services, you need to identify the traffic. After identifying, you need to mark it so that based on the marking, quality of service like reservation of bandwidth, prioritization of a queue can be given. So let us think in this order. First one, in quality of service, what I need to do is classify the traffic by using class map. We classify the traffic, we match the traffic by using class map. And then for that matching traffic, you do policy map, where we map the classified traffic to a QoS marking. And then if a traffic is coming with a marking, we set some privileges. We set some prioritization. Let me explain you. You see, you have router 1, router 2. Let's say here you matched EIGRP traffic. Just for example, I'm saying, okay, you match EIGRP traffic and you have marked with a QoS marking of, let's say, QoS 5. I'll explain what it is later. Assume we have given a number called QoS 5. So where you classified, where you assign this value, this is done on class map. This is done on policy map. Now router 1 is now sending all the EIGRP traffic with QoS 5. Now in router 2, what I'm going to do, I am going to match using class map. You understand? I'm going to tell in router 2, whichever the traffic that has got QoS 5 bandwidth 100 meg policy map. You see, in here, class map is matching with the protocol. Policy map is doing the marking. Whereas on the second router, the marking is used for identifying the traffic. I classify all classes of service QoS 5 in one group. And for all the traffic that is coming with QoS 5, I give a reservation of 100 meg in the policy map. And then where do you apply this? You can apply globally, you can also apply on the interface level. We'll do that thing later, configuration part. Now what I'm trying to explain here is, you need to have a 3-step approach. Number 1, identifying the traffic. Number 2, what to do with that identified traffic. Number 3, where to do this. Apply to the interface or global level. Right? So if you know these 3 steps, you know quality of service configuration part. Classifying is to match the traffic. You can match a protocol, like I used EIGRP, you can use Telnet or SSH or any traffic that you want to, RDP, real-time protocol, RTP, which is a voice traffic. Yep. So class map also used to match the marked traffic. Someone has already marked. That you want to match. Then what do you need to use? Class map. You say class map name this, match traffic coming with QoS 5, and then go to the policy map, call the class map, and set the priority or bandwidth or something like that that you want to have for that particular traffic, and then apply this to an interface. Now, please ask me a question before I go over to the next level. Okay, so far we have seen only this little of QoS. Now, these 3 steps of configuring QoS is called as MPF, Modular Policy Framework. This is how Cisco calls it as MPF. MPF. The other vendors may call it as PBR, policy-based routing. Based on policy, the routing is done here. MPF is Cisco's terminology. Modular Policy Framework, policy-based routing. But the policy-based routing is not only in QoS we have even in BGP. Can we call that as a policy-based routing? Yes. Can we call it as QoS? Maybe. Maybe. There is also a kind of quality of service routing based on policies. Okay, now MPF, PBR, both are same. This is one side. Now let us go to the marking stuff. You see, you write access list and you match the traffic that you will do easily, class map. When we talk about marking, what is that marking? What is marking? See, marking as gold, platinum, silver, copper. This is one way of marking. This is for laymen. If this 4-methyl is given 1 kilogram, and if they ask you to take any one of this 4, which one you will take? You will take platinum because that's more costly than gold. That's right. So I need to rearrange now. See? You know which one is more valuable. Earlier I did not know this. Once I was in Dubai to buy some gold, and they also had platinum. When I asked the price, it was too costly. Then I said, no, I'm okay with the gold. I cannot buy platinum now. It was too much. Then only I realized that platinum is costly than gold. Before that, I did not know that. I thought gold is costly. Okay, so you see, you know the sequence now. If no platinum is a choice, if platinum is not a choice, then you will go for which one? Gold. If gold and platinum is not a choice, which one you will go for? Silver or copper? Silver. You see, so you know the weightage of all this 4 metal. So some people, what they do is they don't want to give marking in a technical manner. They want to just give it in an easy manner for you to do. They'll say platinum, gold, silver, copper options. In the in the catalog, while configuring in a web GUI, if you're configuring QoS, they will simply list these things in the drop-down menu. You can choose any one of this. Can you imagine what I'm saying? For some traffic, when you're configuring through GUI, say for example SD-WAN. In SD-WAN, you are going to tune quality of service. You are going to set quality of service. There, if you go to the drop-down menu in the quality of service, you can say whether it is gold or platinum or silver or copper. You just pick that one, that is enough. Accordingly, SD-WAN will prioritize. So you don't need to know anything technical there to have quality of service. You need to simply apply the quality of service by picking one of this from the drop-down menu. Again, I want to remind you something. Quality of service that you configure is going to be active only if there is congestion. If no congestion, the traffic will be simply going with the marking, but there is no special prioritization. Marking will be there, but prioritization is not given because you have enough of bandwidth. Okay. Now, in a technical side, we don't use this metal name. In technical side, we use numbers like QOS, class of service, which is only 3-bit, which is only 3 bits. Class of service is only 3 bits. In that, for platinum, equivalent to platinum, we have QOS 6 and 7. 6 and 7. QOS 6 and 7, which means what? 0, 110, 111. 3 bits I told you. And equivalent to gold, you have QOS 5. Equal to silver, you have QOS 4. Equal to copper, you have and then equal to aluminium. Actually, there is no aluminium. Bronze. I don't know whether bronze is costly than, I think bronze is costly than copper. You know bronze? Where have you seen bronze? What about this bells and all? The bell that rings in church. Yeah, it is bronze. Here it is bronze. Even the bells in the ancient buses, uh, tramways in Istanbul, they have this tramways, and they have the bell, ding 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 ding. It will be ringing, so that all the vehicles will go away from the way. They won't use a big horn. They use bell, ding 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 ding. Very interesting, very interesting. Okay, now for copper it is 2, equivalent 2. And then for the rest of the traffic, you can say COS 1. And no QoS, 0. No QoS, this is what first in, first out. And you have set priority, you have marked important traffics based on the severity. For the rest of the traffic, you can say this one instead of leaving it 0. 0 is no QoS. With 1, you can provide some sort of QoS for the rest of the traffic. So I want to repeat again. Class of service from 0 to 7, in which 6 and 7 we cannot use it. We cannot use it. 6 and 7 are for protocols, management protocols. So you no need to specify for EIGRP. I just took a EIGRP as an example in the previous example. But for all routing protocols and management traffics, COS 6 and 7 will be assigned automatically. They're already classified. But the other protocols that you are going to use, the vendors don't know what all you are going to use. So they say, fine, I give you option. From 0 to 5, you can choose and you can set the severity level. Okay. This is about class of service. 3 bits. And this is layer 2. But it doesn't mean that I cannot use this in a router. Please, I want to make this very clear. You see, even though it is COS layer 2, so do you hear me? Okay, even though it is a COS, the COS bits are in layer 3 header. Sorry, layer 2 header. Layer 2 header, not in layer 3 header. Even though it is in layer 2 header, but on a router, if you want to set this layer 2 priority for a packet, you can do that. Because router has got authority over both layer 2 and layer 3 header. Do you agree? When a packet arrives, it opens layer 2 and layer 3 and changes the MAC address in the layer 2, which means it has got authority to do alteration to the layer 2 header. Routers got authority to alter the layer 2 header. In that only you have COS. So you can definitely configure, you can very well configure COS on a router. Router will apply to the layer 2 header before sending it out. So what I'm trying to say here is QOS is a marking for packets, QoS marking on a packet in layer 2 level. What about layer 3? I told you QoS can be used in layer 3, but you also have layer 3 header reservation for QoS. See, in layer 2 you have reservation which is called COS bits. In layer 3 also you have reservation that is called as type of service 3 bits. Type of service. COS is what? Class of service. Class of service. That is layer 2 header. Even on router, if you configure COS, it won't affect the TOS bit. It will only impact the COS bit in the layer 2. But only when you set TOS in the router, the impact will be made to the layer 3 header of the TOS field. You understood? Right. So what do we have here is 3-bit layer 3 reservation bit. Now, in layer 3 header, you can also increase the bits from 3 to 6 by enabling a marking method called DSCP. DSCP is not DHCP, it is DSCP, differentiated service code point, differentiated service code point, DSCP, differentiated service code point, DSCP. Right, that is up to 6-bit. You can use up to 6-bit. Right, TOS 3-bit, DSCP 6-bit. COS is also 3-bit. Difference is this is on the layer 2 header. Can we configure this on the router? Yes. Both switch and router can be used to configure. This is configured only on the routers. This will impact only the layer 3 header. Now, we need to go to the next level. What it is, we have 3 types of QoS. Number 1, insert. Number 2, diffser. Number 3, you already know. Integrated services end-to-end. Differentiated services hop by hop. FIFO, you know. Right, so more about this is what we need to start in our next class. 3 type of QoS. What we have seen is 3 different type of marking, which is COS, TOS, and DSCP. And also, the other type of marking is using the metal names. Not available in all operating system. In some command line also it is available, but not in all command line, not in iOS router. It is definitely available in ASR device. Gold, platinum is available. This is also available. COS, TOS, this is also available. You can use both. But in the web GUI, most of the advanced vendors, most of the well-known vendors in web GUI, they keep only these metal names. They don't say COS3, TOS3. They don't go that technical side. They want to make sure that even a layman can configure QoS. We have different type of marking. Earlier we also saw what is QoS. Routers by default don't have that ability to differentiate. Router is like one untrained what to say, untrained supervisor. Now you train the supervisor to classify the people according to their age, so that They will all understand the traffic. So you take the router and say, hey router, if these things are matching, say for example, if you see telnet traffic, if you see SSH traffic, they are very important than any other traffic because someone is doing management level configurations and things on so on, which are more important than other passing traffic. So we tell the router this is special traffic. We educate the router by configuring. By default, according to the routers, all are traffic. There is no important or less important. All are traffics. But that's not good approach on the router. Right, sir. I'll say